Welcome to Section 5, Lesson 1, Video 2. Here we're going to explore the formula for volume of a right cone. So to start, let's consider a cylinder and a cone that have the same height and radius, like we have here. They both have a height, say, h, and a radius of r. Is there a relationship that exists between the volume of these two shapes? So we know that the volume of a cylinder is pi r squared h, so then what would the volume of the corresponding cone be? So we're going to perform a similar experiment as in the last video when we looked at a pyramid and a prism. So here we have our cone and cylinder with same radius and height. I'm going to fill up the cone with water and then dump it into the cylinder. How many times do you think we would need to do this? So we already have one, and here's our second one, and it looks like just one more will do it. So there you go. We can see that it does indeed take 3 cones to equal 1 cylinder, a similar relationship that we discovered for the pyramid and the prism. Now, just like the pyramid, the volume is going to use the height instead of the slant height. Now let's take what we just learned about the relationship between the volume of a cone and the volume of a cylinder to write our formula. A cone is 1/3 the size, giving us this formula here. So now let's use our formula in example 1. Determine the volume of the right cone. So we'll start by writing our formula, and then we'll just fill in our values. I see that the radius is 6.3 and the height is 9.8. So when I plug that in the calculator, multiply pi with 6.3 squared and 9.8, and then divide by 3, I get 407.3 centimeters cubed. Now in example 2, once again we got to determine the volume of the right cone. But here I notice that we're given the slant height, not the height. So that's the first thing we got to do. We find the height by creating a right triangle and then using the Pythagorean theorem. So now let's fill in my side lengths. Notice that up top I took half of 21 to give me 10.5. Now when we're looking for a leg and not the hypotenuse, you can write your Pythagorean theorem as the hypotenuse squared minus the other leg squared, giving us 28 squared minus 10.5 squared. Now if you put that in the calculator and work it out, you should get 673.75. Now to find h, we need to find the square root of that. So you can just put that into your calculator to get a h value of 26. So now I can write that on my cone and now use my formula. V equals pi r squared h over 3. Now the radius is 10.5 and the height is 26, what we just calculated. And when you work out the numerator and then divide by 3, you should get 3001.8 cubic feet. Now in example 3, it says the volume of a right cone is 14.4 millimeters cubed. What is the volume of the cylinder that has the same radius and height as the cone? Well, let's think back to the relationship that we discovered through the experiment. A cylinder has a volume that is 3 times that of a cone. So since we already have the volume of the cone, we can just multiply that by 3 to give us the volume of the cylinder. And that works out to be 43.2 millimeters cubed. Now in this last example, it says a piping bag will be filled with icing to decorate a cake. The bag is cone-shaped and stands 27 centimeters tall and 16 centimeters wide. If it is suggested to fill the bag only 2/3 full, how much icing can the piping bag hold? So let's draw a diagram to see what we have here. We have our height and we have our radius, which would be half the diameter. So that means we can just go ahead and plug these values into the formula. So I'm going to start by finding the total volume, and then I'll find 2/3 of that after. So if the radius is 8 and the height is 27, we would have this. Now multiplying pi with 8 squared and 27 and dividing by 3 should give you a volume of 1,809.6 cubic centimeters. So now we need to find 2/3 of that. So we just multiply our volume by 2 over 3. And again, you can do that on the calculator to give you a value of 1,206.4 cubic centimeters. So now just putting that in the statement, we can say that the piping bag can hold around 1,206.4 cubic centimeters of icing. So now that you know the formula for volume of a cone, you can move on to the next video in this lesson.